That's okay. I'll pick this up here. All right, because I totally forgot yesterday too. Okay, so if we pick up at slope, and sorry, that is example 3. So you do see that in the problem at the bottom of page 130, the one we just did, but I just wanted to go through it again. And then they're talking about it here as well. So slope. That is not what I told you to do. Let's try this again. Nope. I don't have time for that. There we go. Slope and slideshow from current slide. That's what we want. Okay, so slope, the slope of a line, we're saying that line is named M, is the ratio of its rise, which is its vertical change, to its corresponding run, which is what we call the horizontal change. Which part of the Cartesian plane is vertical? Which axis? Y. Which one is horizontal? X. So we always do horizontal to vertical. So your rise is the vertical change. So it's the change in your Y axis. And the run is your horizontal change, left and right. So that's the change in your X axis. M equals rise over run. Here's another example. It is the second Y coordinate minus the first Y coordinate over the second X coordinate minus the first X coordinate. Rise over run. So remember, rise and run, that's just the difference between the 2 points. All right, so let's look at slope from a graphical standpoint. So here we have the line with 2 points, point 1 and point 2. Our rise is the difference between y's. And so point 1 is x1, y1. Where does point 1 sit? What is x1 here? Looking at the graph. Y'all see that? What is my x1? What is x right here? 0. What is x right here? 1, 2, 3. What is my y? 2. It's positive in both cases. So our coordinate for P1 is 3, 2. And then P2 is more, right? 1, 2, 3, 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. So it's 6, 5. And then you just find the rise over run. You plug in those values of its coordinate, and that's how you calculate its slope. So slope, we can go more into slope if you feel like you need to sort of understand why it exists. It really kind of talks about the direction that the line is inclined toward, and how high or low that incline angle is. Except it's not focused on the angle, it's directional, right? So the slope tells you how close to vertical or horizontal you are, and it's going to tell you whether it's heading in the negative X direction or the positive X direction. Okay, so let's find the slope of the line. This is example 4A. So we know our, what? That was confusing. Okay, so for A, they're just giving you a graph and you calculate it. So we see that our Y is 2, and what's our X for that very first, that top point? See where rise is -3? What are the coordinates there?
Wait, sorry.
What's my X? If a point exists on the y-axis, what is my X? 0 every time, right? Yeah. Because on the X, it's on the horizontal plane, it's dead center, which puts it at the origin. The y-axis goes through the origin of the x-axis and vice versa. So your X is 0. So For the second point, your X is 1, 2, 3, 4. And your Y is -1. What? Are you just totally confused?
Not really, just, yeah.
Just struggling. Okay, so B gives us no graph and it asks us to find out the slope of the line that goes through 1 and -4 and 3 and 2. So let's just do this. I think we got this. I know. Okay, so we have 2 points and they want to know calculate slope. Our first point is 1 and -4. Huh? Oh, yeah, that's right. I forgot it does that. Okay, here we go. How about that? Can you see it now? Okay, so x1, y1, x2, y2. Oh, yeah. I helped my daughter with this with her 7th grade stuff. So you've had it for a few years. Okay, so slope M equals rise over run. And rise is what? Right. Think of going up, you're rising. So it's y axis. Your hand motion was correct. It was just the axis number. So the rise is y2 minus y1. And then run, we run along a right. So x2 minus x1, y2 is 2, y minus y1, which is -4. What happens when we subtract a negative? Yes, excellent. So this is just 2 plus 4, which is 6, and 3 minus 1, which is 2. Yeah. So my slope is 3, which is unusual. A lot of times slopes are fractions, and you just leave them as fractions. Yep. Okay, so at the bottom of page 131, they talk about when moving from left to right. So when the incline is uphill heading to the right, it's a positive slope. When it's downhill headed to the right, it is a negative slope. When it's horizontal, this is important, straight line has a slope of 0. And a vertical line is the same as having a 0 in the denominator. It is undefined, impossible, cannot happen. Calculators explode. You can't do it. Right. Well, then don't be late. Oh, right. So homework. Everybody write this down for homework. Right here. 10, this is every third one from 10 to 28. So 10, 13, 16, 19, 22, 25, and 28. You also note cards on the page 132, you have the parallel slopes postulate and the perpendicular slopes postulate. So I want you to take a look at those, but we will be working on those in class tomorrow. No, we're going to be working on problems that address those postulates tomorrow. I don't believe any of your homework applies to those postulates. You instead will be calculating slope. Yeah, you're dismissed once you get your homework written down. All right, thank you.